Ugh. Squeak. Hey everybody, welcome to the Tone Church or the Tone Priest or whatever we call this thing. Rock and roll extravaganza. Special episode today. They're all special, but this one's extra special. A couple weeks ago, I was watching the old YouTube, and Joe from Gray Bench Electronics.
Hey, this is Joe, Gray Bench Electronics.
Put out a video, and he created and built his own take on an Earthquaker Devices Zap Machine Germanium fuzz pedal. How cool is that? And at the end of the video, he said, you know, hey, I got like 10 extra of these PCBs. If you're interested, hop on to my Reverb channel and buy one. So I was like, yeah, I'll have one of those. So that's what we're going to do. We're going to put together a Gray Bench Electronics Zap Machine. Is that what it's called? Zap Machine? Zap Fuzz? Zapper? Frank Zapper pedal?
I guess you don't have anything better to do tonight, huh?
Thing. Yeah. Sound like fun? Sounds like fun to me. Alright, if that interests you, hang tight. Here we go. Alright, everybody. You're going to have to be patient with me today. The Tone Priest has a cold, and it's literally worse than when I had COVID. Both times. But we're going to break the inertia, and we're going to power our way through. Alright, so as I mentioned, I bought the PCB from Gray Bench Electronics Reverb page thingy. Oh god, this is going to be rough. Anyway, great seller on Reverb. I had a notification within like 15 minutes of making the purchase. He sent me the build documents. 5 stars. Well, I'll give you 5 stars once this shit all works. But that's pretty much guaranteed. So here is the schematic, and we'll go through it as we build it. And there's a couple other pages, but I only printed these 2 out. There's this stuff here. Can you read that? Yeah, it looks like you can read that. Let's get some light over here. Important stuff. If you're going to build an effects pedal, you probably want to read all the important notes to avoid any problems in your build. Alright, so that's that. Let's get the PCB in question out. And here she is. Come on. Come here. Came like this. Little baggie. You can stick your, after you take a PCB out, you can stick your narcotics in there and save them. Here's the board. Oh, the lighting in this video is terrible. Here's the board. It's very nice. It's thick, through-hole, double-plated. Nice silk screen. You can read everything. If I had to guess, I'd say this board was made by Ion Effects, which is a very reputable PCB manufacturer, maker. But that's just a guess. We don't know for sure. The other components we bought, I bought the majority of the stuff for this pedal from Small Bear Electronics. I believe Joe buys his stuff from, what is it, lovemyswitches.com? Something like that. I haven't used them. I use Small Bear because they're basically right up the street from me. So I get my shit quick. But here's all the junk we're going to need. Got the enclosure screws, got some washers, got our right angle PCB mount, potentiometers, got some nice green knobs. I went with green because the original Earthquaker pedal, I believe, is in green, so we're harkening back to that. Little foot switch. I believe this is a low profile or a smaller enclosure. It's not a soft click, but it's not especially hard either, so I never used one of these, so we'll try it out. We have our 2 silicon transistors we're going to need. One I bought from Small Bear, one I had in stock. More knobs. One with these jacks instead of the Switchcraft jacks. Looks like this is the way to go for pedals, especially since you're fitting 10 pounds of crap in a 5-pound bag. You know, it just seems like the thing to do. And, oh boy. So, if you're a regular viewer of this channel, you're probably saying, but Tone Priest, didn't I hear you say you hate fuzz pedals and you hate germanium, well, that would be a true statement. Fuzz, I don't. Fuzz for me is not really my thing. I like Smashing Pumpkins as much as the next person, but I saw a video by Louis Johnson. I think that's who it is, Louis Johnson. I'll fix that if that's not right.
Please say hi to my good friend Louis Shelton.
But anyway, he was showing how he used a tube screamer with like the gain just barely cracked. And it just brings a little bit of life into his sound through his amps. And so that turned the old light bulb on my brain. You know, you build a fuzz pedal and you turn the gain all the way up and it sounds like, you know, buzz bomb. No, why don't we crank the gain down a little bit and just get a little bit of hair, or a little bit of fuzz, if you will.
Did you see what I did there?
On your sound, and maybe we can get that nice Gilmore sound. It's not really, you know, buzzing your brain out like the Smashing Pumpkins or like some stoner doom metal. Just a little bit of hair, a little bit of sustain. I notice on, you know, my amps, you know, when you play a chord, you got a lot of nice gain and saturation, but when you play single notes, it just sounds like a clean string. So we want to be able to play single notes and have a little bit of hair on it. And I think this might be the pedal to do that. Hopefully that all makes sense. Anyway, germanium, yeah, I like stuff that works. So silicon's better, I guess. But germanium is apparently super cool and full of mojo, so you got to do it. But it can be finicky. You know, a lot of this stuff is a million years old and big variance and tolerances and stuff. But go over to Gray Bench. He's a germanium aficionado, and I am most certainly not. But I had to buy a germanium transistor for this pedal, and look what we got here. Can you see that? Can you read that? Oh, yeah.
Genuine RCA.
Yeah. You know this sucker's gonna work. Hell yeah. What is this, a 1N1302? I think he used the 1304 in his. But again, we don't want to buzz bomb our pedal. We just want a little bit of hair, a little bit of fuzz. So we went with the RCA. What do you think about that? Oh yeah, Nipper likes it. So yeah, we know the sucker's gonna work. We didn't need to buy 2 or more. RCA, it's the way to go, baby. Blah blah blah. All right, let's put it together. Here we go. All right, if you've never done this before, then you probably shouldn't, because it's electronics and electricity, and it's freaking dangerous, and you'll get electrocuted and burn your house down. This is for entertainment purposes only. But if one were to do this, a couple other things you're going to need are resistors, obviously. And I'll put a link for this thing in the description below. But I got this on Amazon, and it served me well. It's got a million zillion resistors. Every resistor you could ever need for building a pedal. You're going to need capacitors, and these are polycaps. And 3 kits is pretty much all you'll ever need. Put links down below for those as well. And we're going to need electrolytics as well. Bam. So I think that's everything we should need. I didn't really check the schematic and check to see what I had in stock, but I feel confident that we have everything we need to build this pedal. So without further ado, or a don't, let's warm up the soldering iron and get to it. If you've never built a pedal before, a fuzz pedal is a good place to start. You know, there's not a whole lot of crap in here. I would go with a silicon fuzz because of all the aforementioned issues that germanium brings to the table. But whatever. Do what you're going to do. Make it happen. Alright, a couple other things we're going to need. We're going to need an LED holder, like so. And we're going to need a 9-volt jack to power our pedal. I don't mess around with batteries. I just use the power supply. When you're buying these, don't get the metal ones, because if the metal body is, what am I trying to say? The cold's killing me again. A lot of pedals, most pedals, 99% of pedals are center grounded. And so the outside, you have your positive voltage. And if that's not isolated from the metal body, it will be bonded to the metal enclosure, which is bonded to ground. And that's what we call a short circuit. Ask me how I know. So go with the plastic ones. All right. I like the ones, I don't know if I have any more. I don't like this kind because you have to solder the wires through the hole, and then if you need to take your board out, you have to desolder the wires. You see how the nut fastens? I like the ones that go this way. So you stick it through the hole from the inside and then screw it down. That way, if you need to take your board out, you can take this nut off and then pull it out and pull everything out. But if I have any more of those, I'll switch this guy up. But not the end of the world. Alright, so I was just looking at the build notes that Gray Bench sent to us, or sent a link to, and it doesn't appear to be a bill of materials. I could be wrong, but if I'm not, that would be very helpful, because it's nice to have, you know, all the resistors you're going to use in a list, all the capacitors, all your components, so you can methodically go down the list and check it off as you install it. So that'd be a nice thing to add, Joe, if you're watching. But again, there's not a whole lot here. We'll be fine. You know, everything's labeled nicely on here. We'll get her done. All right, getting the soldering iron or soldering iron warmed up here. Soldering iron. So what the plan is, when you're building a pedal, you want to install the components that are smallest or least high from the board, and then work your way up to the bigger stuff. Bigger stuff usually starting with the diodes, then the resistors, then like whatchamacallit, sockets if there are any, and then polycaps, electrolytic caps, trimmers before them, whatever. You'll see. And it's just easier to do it that way. So we're going to start with diodes. We have a diode kit here, and it looks like we need an 5017. Hopefully we have one of those in here. Wow, that is disgusting. You see that? Well, it's time for a new one of them. Ugh. 5017. What do we got here? 1N. 5817. 18. That's 3. Oh, I'm going to have this. You're going to have to find a substitute. We'll pick this up later. How do I not have this? This is ridiculous. Hang on. My bad. It's a 5817. Right here. Bam. 5017 probably isn't a thing. I need one of these bad boys. Oh, looks like the first one of these I've ever used. Good times. Alright. 5817. Nope, no. Yeah. Alright, I'll install this. Sorry about the squeaky chair. I will show you my technique. Can you see all that? I'm going to get a little bigger here. Here we go. Put you in the middle. Show you my technique. Alright, I'm not telling you what you should use, but I use leaded solder with plenty of fresh air in the shop. Does that make sense? We'll get the soldering iron in the shot here in our little, this thing. I want a nice clean tip. And we're going to tin the tip. Keeps all the gunk off of it and helps transfer heat as we solder. As we are soldering. As we're soldering. Board. Diode. And if you have, especially if you're using like NOS components or Mojo components, you know, the leads could have a bunch of gunk on them and, you know, 50 years worth of spunk. Grab yourself an eraser, pink one, white one, that's fine. Give it one of these. And one of these. And then you can go back with some alcohol. The higher percent, the better. Isopropyl. But we're getting a little carried away here. It's completely unnecessary for our purposes here today. Alright, so this is going to go in here. Diodes are polarized, meaning there's a right way and a wrong way to install these. Going to bend the leads over, 90-degree angle. Hopefully this should fit right in, if the spacing is correct. Alright, we got the line on the right. Line on the right. Jam this sucker in there. You want it flat against the board. And I don't bend the leads over when I'm doing pedals or anything like that, unless there are exposed traces on the underside. If that's the case, then I'll bend the leads over in the direction of the traces, clip it, and solder it. But these components are very light. It's not like there's going to be a lot of stress, and there's a chance of vibration, or a very low chance of vibration, loosening up the joint. So we'll be fine. Yeah, we'll be fine. Don't worry about a thing. Again, if you're new to this, quick tutorial on soldering. You're not blobbing melted solder onto your parts. What you're doing is you're heating up the component and the PCB pad, and then introducing solder to the heated component and pad. And if they're both up to the right temperature, it will melt the solder, and then the solder will stick, and it all will be good in Denmark.
And wicked dreams abuse the curtain's sleep.
And again, I have a cold, so I took a couple Excedrin, and I drank a enormous iced coffee. So we are overdosing on caffeine at the moment, so this should be fun and exciting. All right, but anyway, I like to use a chisel tip. Use whatever works for you, but I recommend a chisel tip. What we're going to do is we're going to kind of go straight down with the flat edge of the chisel tip up against the lead, the point of the chisel tip against the pad, and we're using this thing to push down to keep the component flush against the board. And get a little bit of tin on the solder. Oh, yep, caffeine. We're highly caffeinated. One, boom, boom. That's all she wrote right there. See that? Should look like a little metal Hershey Kiss. When you're soldering, you get a technique. You get good at it after you've done a couple 100,000 of these. But you'll see the solder melt, and then a millisecond later it'll get watery. You're done when you see it get watery. All right, down, in. Done. All right. And then we get our flush cutters. You're not going all the way down to the board. You're going to the top of the Hershey Kiss. Clip. Clip. Discard. You see that? Done deal. All right, we're going to check to see if there's any more diodes on here. If there are not, we're going to move on to resistors. So I'm going to start installing the pieces, and we'll check back in with you in a few minutes. God. Feeling rough, people. All right. So we get a 1K. We're going to start top, bottom, left, right, sort of. Got a 1K in the top left. We're going to check to see if there's any more 1Ks. I see one. So it looks like we need two 1K resistors. So what we're going to do, grab our 1K resistors. Ooh, can't get them open. I'll grab two of these. These are 1/4 watt resistors. I believe this board spacing is for 1/4 watt resistors. And we'll be able to confirm that presently. That's usually what people use in pedals. Where did we find you? Get back in there. 1, 2, you must go right here. Alright. Damn. I need more space on my bench. I don't need a gray bench. I need a bigger bench. Alright. So, yeah. Here we go. Got our 1K. Bend the leads. 90-degree angle. Stick them through the hole. And just be careful. Because some of these values, you don't want to stick a resistor where a capacitor belongs and vice versa. the resistor, the symbol, or the screen printing. Looks like a dog bone. And then the capacitor is like this guy here, 10N. That's kind of ovulating. Whatever, ovulangle. Anyway, just be careful. Stick them in. Looks like we want to bend these really tight to the body to get them to fit. But that guy will be fine. He'll be fine. Stop worrying about everything. You see that? Yeah, you can see that. Is it in focus? Probably not. What are we focusing at here? Oh, God. This is terrible. It's terrible. But out of focus is kind of my world at the moment with all the coldness, viral infection. Again, we're pushing down with our finger here. This finger here. We're pushing the board down with, while we're holding the solder with the other ones. And just like before, oh God, why did we do this today? Get our solder on there. Solder. I got a master's in soldering from Harvard. When I got my master's, I was able to move out of Southie over to Wellesley. And that's when I became an insufferable... Oh, pardon me. I don't know what's come over me. Must be all the antihistamines. Anyway, there you go. Boom. Let's do another one. Like I said, we want to bend these really tight to the edge, and it should fit in there really nicely. Can you see that? I'm not paying attention. Yeah, nice. Push it in there. Solder. Don't make fun of how I say solder, you aluminium bastards. Aluminium, that makes absolutely no sense at all. Aluminium. People have lost your minds. Boom, there you go. Alright, let me put the rest in. Alright, we did a little bit of an oopsie. My 1K resistors, I used up all the 1K resistors from the big kit you saw, so I bought some replacements, and it's from a different manufacturer, so they're a little bit bigger. So now that I'm putting in this 12K, you can see it's considerably smaller. So when I push it down, it's not hitting this metal thing here, this cover, and pushing it flush to the board, because the resistor right next to it is bigger, taller. So what we're going to do is just bend the legs a little bit, and that'll squeeze it up flush against the board. So, for what it's worth, there you go. Alrighty, I got all of the resistors in there, looking pretty nice. And I don't know how well you're going to be able to see this, but the printing on the board, especially for the capacitors, there's not a whole lot of room. Like this one here next to the Gray Bench logo, 0.00, no idea. So what we're going to need is the board drawing, and he has provided that in the link to all the build documents. And well, let me show you. And this is another little bit of constructive criticism. So this is the drawing he's provided, which is very good. And the only criticism I would give this is the white letters on the black background. We're going to want to print this out, and we're not going to want to use like 3 cartridges worth of black ink to print it out. So I just copied that. I brought it into GIMP, and I inverted the colors. And this is what we have. Yeah, that's all. Nothing major. But we can, as you can see, you can read what all the values are for the capacitors. So we'll be able to build this properly. And then one other quick tip when installing resistors, just watch your decimal points. There's a big difference between a 47K and a 4.7K, or a 2.2K and a 22K. Just be very careful. So, next thing we're going to do, I think, will probably be this trimmer. And then we're going to add a socket for the germanium transistor. Sockets for transistors, op amps, are always recommended, but especially for germanium, because there is such a variance between one to another, even of the same type. And it'll also allow you to experiment. You can just pop one out and stick another one in. So we're going to stick our socket in, our trimmer in, then we're going to move on to the ceramic capacitors, then the polycapacitors, and then whatever else is left. So hang tight, here we go. Alright, we're going to install our 20K trimmer, and this is to bias the germanium transistor. And as you can see, there's two main types of trimmers. There's one with the 3 legs that are like this, with 2 legs on one side and 1 leg on the other. And then there's this kind where there's 3 legs all in a row, like so. This board is looking for the, where's my finger? 2 legs on one side, 1 leg on the other. So when you're buying your stuff, well, actually this board's probably not available anymore, but I imagine if you check your favorite clone board manufacturer website in the near future, something very similar to this will be available. And yeah, you're going to need this one. Alright. Here's our trimmer kit. There'll be a link in the description below, Amazon affiliate link. A couple videos ago, I let y'all know that Amazon sent me an email saying, hey, you haven't sold any crap, and if you don't sell 3 things within the next 90 days, then we're going to fire you. Again, I'm not trying to earn a living by Amazon affiliate links, but if it can buy a 12AX7 after a year, there you go, that's a good thing. But links for all the crap you'll need will be down below. Alright, we got our, what do we call that thing, socket and our trimmer installed. Now we're going to move on to the capacitors. Ignore this yellow highlighter, I got a little overzealous. We're going to start with the smaller values, so the picos, get those installed, and we'll move on to the nanos, and then we'll move on to the micros, which are usually electrolytics. And then last but not least, we'll install the transistors. And yeah, riveting. Here we go. Alright, we got our first one installed right here. Ooh, what's going on here? Uh-oh. Somebody lost their ink. Probably getting that everywhere. Anyway, that was a 470 pico. We got 100 pico over here. So it's going to go here. You see that? There. And as we go, we're just going to highlight them so we don't miss any. But it's a small board. We probably won't miss any anyway, but can never be too safe. This is what we're going to do. As you can see here, this trimmer is actually pretty high. We probably should have waited to stick them on there, but never fear. Objections lead to opportunity. So 100 pico goes in right here. Stick them in, flip them over, and we're just going to bend the legs. And we want to be mindful where we bend the legs. So this top leg here, I don't know if you can see that. Let me get Mr. Pointer. We don't want to bend the leg towards this pad to try and avoid shorts. I mean, it probably wouldn't because we're going to trim it and stuff, but we're going to bend them this way, and we'll bend this guy down like that. And that should hold that guy nice and snug in there. Let's put you like so. And then we'll solder her up. There's something else I wanted to talk about, but I can't remember. For the light, oh, polarization. Yeah. The polycapacitors and ceramic capacitors are not polarized, so it doesn't matter which orientation you stick them in. But the electrolytics are. And tantalum capacitors, if you happen to have any, which I do not believe this board does or calls for, but tantalum can also be polarized, so you don't want to stick those in backwards. Alright, there you go. How's that look? Getting there. Let's get some light in here. Here we go, that looks good. Yeah. Alright, moving on. Alright, we got all those capacitors installed, and I believe all that's left for passive components, or these little guys anyway, are these 3 electrolytic capacitors. These all came out of this kit here. Alright, and electrolytics are polarized, meaning there's a right way and a wrong way to install them. If you can see, this has a long lead and an out of focus short lead. Are we focus in here? Focus. Lights. Oh, this is definitely not Scorsese quality. Anyway, there's a long lead and a short lead. The short lead is the -1. The long lead is obviously positive. If you look here, there's a white stripe with a minus sign and an arrow pointing at that short lead. So there should be no excuse for installing these incorrectly. Also on these, there's a voltage rating. This one here, I don't know if you can read that. It says 25V, that's for 25 volts. If you're new to this kind of thing, that's not how much voltage this is putting out, because it's not putting out voltage. The 25 volts is how much voltage it can withstand before it explodes. Most pedals run on 9 volts, but some pedals like the Klon and others have like voltage doublers in them or run on 18 volts, etc. So you want to make sure you have some headroom. You probably don't want to use like a 10 volt rated electrolytic capacitor. You want to have usually at least double. So 9 volts times 2 is 18, 25 is perfect for this. You can use, we could use a 1000, a kilovolt electrolytic capacitor, but, it'd be this big, so there's a balance there. But anyway, so we're going to install this. All right, this guy here, and you want to, if you have a kit like I do, you want to make sure you read the value on the side of your capacitor, because the at night the capacitors like to jump into each other's little containers there, and that'll screw you up. Anyway, this is a 4.7. That goes right here, and if we see on the board, probably not, but there's a little plus sign over a square pad, and there's nothing over a circular pad. So the square pads are for the positive, which is the long lead. So it'll be oriented this way. And if you assemble a pedal and it doesn't work and it exhibits some strange behavior, that would be the first thing I would check, is to make sure all your polarized components are polarized in the right orientation. That all makes sense? Pretty simple stuff. Just care and patience and attention to detail on this kind of thing, and you shouldn't have any problems. All right, and solder. And then I'm going to use our flesh cutters. Go out and get the good flesh cutters, nice stainless steel ones with a nice super flush cutting surface. Don't go to Harbor Freight for these. These are, these are only like $10 for the good quality ones, and they're well worth the extra couple bucks. Clip it at the top of the Hershey Kiss, and there she is. Looking nice, right? We're almost done. All right, we're going to install the 2 silicon transistors here, and if we look at the screen print, we can see it's a circle with a flat side on it. And we're not using alternates or substitutions. We're using the exact transistor the schematic calls for. But if you do use alternates, you're going to want to make sure you know what the pinout is, the base, emitter, and collector, and make sure you orient it the correct way. But these should work out just fine because we're using the exact ones. So we'll stick that guy in there, that guy in there, and we'll solder them up. You see that? No, can't see what I'm doing. What's he doing? It's a secret. Oh God. There we go. And if you want to be real fancy, you can get a specialized PCB holder that flips around and holds it steady and all that, but we're not special here. Not for you. You want to be very careful soldering your transistors. You definitely don't want to overheat them, so get in and out as quickly as you can. Like so. I'm going to go back to this guy. And you can also use a heatsink. Clip it onto the leg you're soldering. Wait for the motorcycle to go by. Clip it onto the leg you're soldering on the other side. And then that will help ensure you don't overheat your transistor. But as you can see, that would be difficult here because we did not account for that when we installed all the other components. But we'll be fine. I have faith. Alright, let's wrap this up. Get in there. Done deal. Not the prettiest solders in the world, but they'll work. 1, 2, 3. 5, 6, 7. Done. Alright. Now it's time to put the potentiometers on there, and then the off-board wiring, and we got the on-off LED as well we're going to put on, but that can wait. Almost done. It's pretty quick. I've only been working on this for about an hour, so it's going together nicely. Alright, let's do it. So this PCB and this schematic, the circuit, calls for 5 potentiometers. A volume, gain, treble, bite, and bass. Alright, if you're new at this, you'll see the values for a potentiometer like this one is B, 100K. K stands for kilo or 1,000. What is up with Mr. Motorcycle today?
And he's not hesitating. He'll go.
K stands for kilo or 1,000. So 100,000, 100K, 100,000 ohm potentiometer. B's normal. A stands for audio, which means as you turn it up, it goes slowly up, slowly up, slowly up, and then it curves up like that. So instead of when you turn it, you know, the resistance doesn't go up at a nice even rate. It's sort of like a hockey stick. And then C, like this C1K, C1000 ohm potentiometer, C is reverse audio. So it goes up a lot, and then it slowly turns down or something like that. You know what I mean. So they did not have one value we needed, which was, I think it's this audio 500. Yeah, they didn't have an audio 500 in stock, so I got a B or a linear 500K, and that'll be fine. What would be bad would be a C or a reverse audio 500K. That would be completely, you know, defeating the purpose, but a linear will be fine. It'll just be a little touchy in a certain part of the range. Right angle, you can see these tabs right here. We're just going to break those off. We don't need those. So grab your pliers and pop that. Wrong pliers. Wrong pliers. Grab these pliers here and bust that thing off. Yeah. Cha-cha. Alright, let's do it. Okay, the potentiometers mount to the opposite side of the little city we built here. And if you can see, you know, there's the potential of the metal body of the potentiometer to touch all the ends of our passive components, which will create all sorts of short circuits and stuff like that. So there's a couple things we can do. We can take a little piece of non-conductive material, like a piece of cardboard or a piece of plastic, and wedge it in between the back of the circuit board in our pots. Or we can get these things. I got these from guitarpedalparts.com. They're like 15 cents each. And if you can see, there's a lip on here that goes like so. And we call these things pot condoms. Stick that on there. And voila. That will stop any short circuits from happening. Alright, I'm going to flip it over and we're going to solder that. And easy peasy. Alright, now it is time to do the off-board wiring. And from the build documentation, this is how the triple pole double throw foot switch is going to be wired. And using the colors of wire I have available, this stuff here, Ground will be black. Input jack will be white instead of green. I don't have any more green. The LED negative will be orange. Board out will be blue. And the output jack will be purple, as labeled. And then these are to the jumpers here. What do we want to call these? Pads on the board where those wires are going to get connected. And then after that, we're going to need these two pads are going to go to our 9-volt input jack. And then we're going to have 2 1/4-inch jacks for the guitar in and guitar out. And there'll be wires, positive and negative, for each one of those up here on the top. And then finally, our LED. Pretty simple stuff. Let me solder the wires in, and it should make more sense after that is done. Alright, we got her all wired up here. Goes like so. Can you see all that? Now you can't see shit. You see that? Colors, etc. Let me take you off of Mr. No, let's not do that. I need both my hands. Now we're going to mock it up. So this is going to sit lower when we cut the holes for this. So I believe this is supposed to go like so. These will fit under here nicely underneath these top pots. Then we're going to have our 9-volt jack in the middle here. Plenty of room for that. We're not going to mess around with batteries, like I said, but there, if you do it right, do things correctly, there should be enough room in there. If you, I'm going to put the pot lower to the bottom of the pedal, but if you put it up here, there should be enough room for a battery, if one were to want to use a battery. Yeah, this is coming together nice. This is probably, technique-wise, and, you know, fitting all the crap in the enclosure-wise, the best one I've done to date. So, yeah. But we're not done yet, so let's get her done. Oh yeah, there is a drill template for this that Joe provided, but for whatever reason I can't get it to print out actual size on my printer. It comes out friggin' ginormous, which would be fine if we were building this into a shoebox sized enclosure, but we're not. So we did some measurementation here, cut out a piece of a green tea box here. That's will fit inside, and then we got our ruler or scale marked out where the pots go, and we're just gonna do that. We'll get one of these bad boys that I cannot seem to find. Here we go, one of these bad boys, and we're just gonna make little marks in the enclosure, and we're gonna drill them out. Pro tip on the drilling of holes for your enclosure: get one of these guys. This is a drill size, fractional drill gauge, I guess is what it's called there. And instead of using like a Christmas tree bit, use the actual, a regular drill bit that's the proper size for the hole you want. So 375 there, which is what, 3/8, something like that. Because the Christmas tree bit just doesn't make as nice a hole. You know, we've got these chamfered edges here, and, you know, which is good for just cleaning up and deburring if you just tap it, but I have found that I have better results when just using a regular 3/8 in this instance drill bit. So pilot hole, 3/8, wham bam, thank you ma'am. Measure twice, cut once, all that good stuff. Alright, next time you see this, she should be up and running and ready to plug in. Alright, so you can see we're getting down to brass tacks here. And right here, for our 9-volt jack, you can see with this style where the nut goes on the jack from the inside, once we solder those wires, there will be no way to pull out the board without desoldering the wires if we need to troubleshoot or anything like that. I am all out of the other style that bolts on from the outside. But that's alright, no biggie deal. We just need to wire on the jacks, and you see the LED. We have everything, we have the board secured in its final resting place, and we have not soldered the LED yet. This thing right here in the middle, right here, can you see that? We put it in loosely, bolt everything down, and that way we get the right distance or height from the board that the LED wants to sit, and now we'll go ahead and solder that down, and that'll fit perfectly. And what else we got here? One more little critique, unless I missed it. There's no ground pad on the PCB for the ground wire that's on the foot switch. And I went and I clipped all the leads that are coming off the foot switch, not realizing that this, I believe, has to go to the, one of the negatives of the input or output jacks. So we had to add a band-aid here, so it'll reach. But that'd be one little critique if we were to redesign this board. Just add a, another pad with a ground for the LED or the foot switch ground. But no big deal. Not at the end of the world. It'll be fine. All right, a few more solder connections, and then we'll fire her up. All right, before we install our 9-volt jack here, make sure you put the nut over the wire. You see the nut down there? Before you pass the wires through the hole and solder it, or else you'll be desoldering it and doing it again. On here, the tag, that's an L shape, that's ground. And then the lower tag is for positive, 9-volt positive, and this upper tag is for your battery. We're not using a battery, so we're not going to be using that. So we're just going to be using the bottom two. All right, there she is. That's definitely the neatest job I've ever done. Still need to socket the germanium transistor and throw some knobs on there, and hopefully she all works. Yeah, not bad at all. Alright, let's do it. Alright, before we inject voltage, we want to do a little bit of probing with our multimeter here, Mr. Multimeter. We have it in beep mode, so we have one of the multimeter leads clamped onto the chassis, and the enclosure is being grounded via the input jacks, the sleeve of the input jacks. Alright, and we want to test the 9-volt jack, the black wire, to see if that's grounding, and it is. And we want to probe the hot lead of the jack to make sure it is not grounding, and it is not, so that's all good. What else we got? Ground here, that's grounding, so that's all good. Alright, I feel confident that we can inject voltage and let the magic electrons do their magic. Oh, one other thing while we're here. You see our germanium transistor? I don't know if you're going to be able to see this. It's teeny tiny. See how there's a little little protrusion on there? A little dimple? If you look at the PCB, there's a little dimple on there as well, so you get the right orientation. Alright, can we get the RCA logo in focus? No, probably not. Alright, let's plug her in. We're going to check the bias voltage on the trimmer. And if we're looking at the trimmer here, the top leg is towards the top of the enclosure, and then the two legs that are next to each other are towards the bottom, towards the foot switch end. And we want to check this leg over here. So clamp the ground, test voltage right there, and that should give our collector voltage, which should be half of our input voltage, which is basically 4.5 volts. So let's plug her in and do that. Alright, so we're testing the pin down here on the lower left. That's our biased voltage through this trimmer. If you turn the trimmer all the way clockwise, you'll have the coldest bias. So if you want to start there, you can. And you do need to have the transistor socketed. And as you can see here, we want about 4.5, and we're just under. That's close enough for government work right there. So she's properly biased. Let's break out a guitar and an amplifier and see what she does. Yeah. Alright, we got her fired up. We got her plugged into the world's greatest Fender Champ clone right there. Put Mr. Tripod back. Hopefully the amp isn't going to blow out the camera speaker here. But I want you to be able to see the knobs as we noodle around. We're on about 3 on the amp. So 9 o'clock. With a Telecaster-shaped object. I can tell already this pedal here has got lethal amounts of gain. So without further ado, volume, gain, treble, bite, bass. And as Joe said in his video, the bite will make a swishy sound. There's DC on the pod, so that's normal. So we'll do unity. That's unity right there. It seems to be a little bit on the gain. There's a dead zone, and then it kicks in. Alright, let's see about using this as a boost pedal. See what, Alright, so we got the gain set to where it's just out of the dead zone. Set everything at noon, see what we get. Ooh, I think we're gonna get loud. Cool, it works. Sounds pretty neat. Definitely need to play with it some more, but let's see if we can do what we were hoping it would do. Give me a second, let me re-rig some stuff up here. Alright, we've had a wardrobe change here. We have my tweed Fender Bassman clone, 2x10, couple of Jensens, one ceramic, one Alnico. Channels jumped. We have this reverb device here. Who makes that? Flamma. Flamma? It's actually Flammer, but we're in Massachusetts, so we call it Flamma. Same thing here. Donna. We got a Donna delay type thing. Of course, we have our Gray Bench Electronics version clone thingy of a Earthquaker Devices Zap machine, or whatever the heck it's called. Zap Fuzzer. And we have my clone of an Electro-Harmonix Electric Mistress. So with this setup here, I think you can guess what's coming next.
babe. Of course, mama's gonna help build the wall.
Well, there you go. There you have it. How fun was that? That was freaking awesome. I love it. I want to thank Joe from Gray Bench Electronics for his great channel and all the work that he does, all the teardowns. If you haven't already, go check him out. If you are into germanium, he's pretty much the germanium aficionado. So, you know, check him out. And he put together a great PCB, and it built a great pedal, and I think it sounds fantastic, and it does exactly what I wanted it to do. So thank you, Joe. Thank you for watching, if you made it this far, or if you didn't make it this far, thank you anyway for clicking on the link, but blah, blah, blah. All right, dudes and dudettes, rock on.
Done!